All right, so here we're going to, in this video, we're going to take a look at solving a different type of problem. In our previous video, we took a look at the sum principle. Right now here, what we're going to take a look at is the, excuse me, the product principle. Now, let's take a look at this problem here. So it states, how many ways can I select an ace followed by a face card? All right. So here we have, excuse me. Let's introduce the product, the product principle here. So I'm going to navigate over to our textbook here. All right, and then here, if we look, it states, if an event A can occur in M ways, and each possibility for A allows for exactly N ways for event B, then the event A and B can occur in M times N ways. All right. So again, here we care about both of these things happening, right? If event A happens, then that can lead to event B happening in a certain number of ways, right? So for example here, right, the one that I have here, I think it's good to kind of visualize a tree here. All right, so if we look at how many ways can I select an ace? So here, some event, and we have an ace, let's see, of hearts, ace of diamonds, ace of spades, we'll use our imagination there on the spade, and an ace of clubs. Right. So we see that can happen in 4 ways, but then the next event, a face card, well, if you look at how many face cards we have 3, 6, 3, 6, 9, 12 face cards. All right, so each one of these allows for that's going to get messy here. All right, so as we can see here, I'll just illustrate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so each one of these is a possible outcome, right, of those 12 face cards. All right, so imagine now this same kind of branching out of the tree in each one of the following 3 aces there. And we add all of those up, right? But again, that's just repeated addition, so it's multiplication, right? So in fact, what the product principle tells me here is that we have our initial outcome, 4 of them, and each one of those can branch off into 12 different face cards here. So in fact, we have 48 different ways that we can select an ace card followed by a face card. Okay, so that is an example of the product principle. All right, let's take a look at another example here. Let's see, here we had so let's look at how about this license plates. So license plates, we have all right, so if we think of license plates, all right, how many different license plates? Excuse me. All right, so standard license plates are 3 letters followed by 3 numbers. Okay, and then here we can, again, 1, 2, 3, 1, 2, 3, and 3 numbers, I should say 3 digits, right, where the digits are 0, 1, 2, up to 9, right? So we can see here, right, that tree branching out. Here I won't draw the trees because these are going to be a significant amount of branches here that we have. Right, so 26, right, if you think of 26 options for the first spot, another 26 there, right? So each one of those branches off, and then from there, each one of those branches off into 10 more digits, right, 0 through 9. All right, and that would give us the total number of license plates using this combination here. So it turns out this is 17,576,000 different license plates that follow this pattern here. Okay. All right. Okay. So another way that we can do this, another example, I should say. So let's say I want to look at the paths that go from all the lattice paths from 0, 0 to 10, 10 that pass through through 4, 7. All right. Okay. Okay, so the way we want to think about this, right, if we're going from 0, 0 through 10, 10, so that's 10, 10, and then 0, 0, and passing through 4, 7. So here, 4, 7. Okay, so the way I want to think of this is I want to essentially split this up, right? If I started at 0, 0, right, what are the different ways that I can get through to 4, 7? Right, so the paths I can take to get here. Right, so again, as we recall, that would be 11, choose 4. Right, or 7, again, as we've seen, these are going to be equivalent numbers, and that in this case, doing this operation, this is 330. All right. Now, the second segment, again, we branch off from there, right? So there's 330 to get us there, and then again, you can almost see the tree in the paths, right? We can take different paths here. So it's going to be the product principle. Now from there, the path to get to the other one is going to be, right, the difference here, right, 6 and 3, right? So 6 units along the X, right, 3 units along the Y. So that would be 9, choose 3, right? Or choose 6, right? Give us the same number, right? And that is going to be a total of 84. So it's 330 times 84, and that's going to be a total of 27,720 paths that go from 0, 0 to 10, 10 that pass through that 4, 7. Okay? So that's another way that we can use the product principle. Now, sometimes we can use it as a combination of both the sum and the product principle. All right, so for example here, all right, so we said, so let's say, all right, from the set 1, 2, 3, 4, 5. How many 2-digit numbers? Again. 2-digit numbers have an even digit sum. Okay. Okay. Now, this can happen when both digits are odd or both digits are even. All right. So here, so I want to split into 2 digits, into 2 disjoint cases. All right. Okay. So 2 disjoint cases. So the first case, we have odd, odd, odd. All right. So looking at that, we could see, all right, here and again, we are allowed to repeat, right? So we can have 11, all right, as well as like 33, etc., right? So looking at our set, we have 1, 3, and 5. So there are 3 odds. So if we fix one of those in the first position, then I have 3 more that I can use in the other position. So that gives me a total of 9. The second case, case 2, that is even, even. Now here we only have 2 evens, 2 and 4. So this one would be 2 times 2 is 4, and then we add these up. So there are 13 possible 2-digit numbers that have an even digit sum. Okay, so that's how we can use the combination, combining both principles. All right. Okay.